Discrete random variables and probability distributions. Random variable. A random variable is a quantitative variable whose value depends on chance. Discrete random variable. A discrete random variable is a random variable whose possible values can be listed. In particular, a random variable with only a finite number of possible values is a discrete random variable. Probability distribution and probability histogram. Probability distribution. A listing of the possible values and corresponding probabilities of a discrete random variable, or a formula for the probabilities. Probability histogram. A graph of the probability distribution that displays the possible values of a discrete random variable on the horizontal axis and the probabilities of those values on the vertical axis. The probability of each value is represented by a vertical bar whose height equals the probability. Sum of the probabilities of a discrete random variable. For any discrete random variable x, we have the sum of p of x equals 1. Example. Determine the probability distribution of the random variable y. A variable y of a finite population has the frequency distribution shown in the table. For the value y equals 4, the frequency is 2. For the value y equals 5, the frequency is 2. For the value y equals 6, the frequency is 4. For the value y equals 7, the frequency is 2. Suppose a member is selected at random from the population and let y denote the value of the variable y for the member obtained. The capital Y is representing the population, whereas the lowercase y is representing a particular data point. First, we need the sum of the frequency, which is 10. That's our sample size, n. Then we set up our table. For this table, our y value is the first row, and the probability of that y value is the second row. The notation used here is p parenthesis capital Y equals lowercase y, close parenthesis. The notation p parentheses y is also valid. To find the probability that y equals 4, first we need to take the frequency of 4 and divide it by the total frequency. So 2 divided by 10 is 0.2. So that's going to be true for 4. 5 has a frequency of 2, so that will also be 0.2. 7 has a frequency of 2, so it will also be 0.2. 6 has a frequency of 4. 4 divided by 10 gives us 0.4. So the probability that y equals 6 is 0.4. 0.2 plus 0.2 plus 0.4 plus 0.2 does equal 1. So our probabilities are correct. Example. Construct a probability histogram for the random variable y. So we have our probability distribution table from the previous example, and we want to create a histogram. You won't be drawing the histograms freehand. You will be comparing them to several histograms to decide which one is correct. So for the graph we are doing, we have y equals 4, 5, 6, and 7 on the x-axis. Our y-axis always starts with 0, and it goes up to 0.5. Going to our calculator, the first thing that we want to do is go to Stat, choose Edit. I'm going to arrow up and clear any data. Now I want to type in my data for y, which was 4, 5, 6, and 7. Then I go over to L2 and I type my probability. 0.2, 0.2, 0.4, and 0.2. Now I'm ready to graph my histogram. Above your y equals is stat plot. Second, y equals takes us to stat plot. Press enter. My first plot is off. With the cursor blinking over on, I press enter. Then I arrow down to the type. I have a dot plot, I have a line, I have my histogram, which is what I want. I have two different types of box and whiskers plots, and then I have another line graph. So I press enter, and that's selected. XList is L1, that's where we typed our values for Y. Arrow down to frequency. Our frequency is in L2. Second, 2. Now we're ready to press graph. And depending on how your graph is set up, it's not going to look like very much. One option we have is zoom 9, which is zoom stat, and it's given us a graph with 2 bars. We don't want that, so we go to window. The graph we were given started with 4 and ended with 7. For x min, we want 4, but for x max, we need to at least use 7. I want to use 8 because I like a little bit of space between the end of my graph and my window. Now for our x scale, we want that to be 1 because we want 1 bar per number. Our y min, we're always going to start that at 0. Then our y max, since our highest probability was 0.4, I want to use 0.5. Because I like a little space between the top of my greatest frequency and my window. I'm going to leave everything else the same and press graph again. Now this graph looks much better. I can push trace and my right arrow, and I can see what each bar represents and its frequency. So I have now constructed a probability histogram for the random variable y. Interpretation of a probability distribution. In a large number of independent observations of a random variable x, the proportion of times each possible value occurs will approximate the probability distribution of x, or equivalently, the proportion histogram will approximate the probability histogram for x. What this means is if we have two histograms, and our first histogram A is the histogram of proportions for the number of heads obtained in 3 tosses of a balanced dime for 1,000 observations, and B is the probability histogram for the number of heads obtained in 3 tosses of a balanced dime. A, we actually flip the coin 1,000 times. For each observation, we flipped it 3 times and had 1,000 observations, so we actually flipped the coin 3,000 times. And then the second graph was a theoretical probability using 1/2. So 0 in both graphs represents 3 tails, 1 represents 1 head and 2 tails, 2 represents 2 heads and 1 tail, and 3 represents 3 heads. Now theoretically, 0 and 3 should be equal. When we tried out our experiment, they weren't quite equal, but they were kind of close. Theoretically, 1 head and 2 tails should be the same as 2 heads and 1 tail. That didn't quite come out when we had 1,000 observations, but it was close. The more observations we do, the closer it will come to the theoretical probability. Example: the following is a probability distribution for the number of Mexican-American jurors X on a 12-person jury. The jury was randomly selected from a population in which 80% of the people are Mexican-American. Use the special addition rule and the probability distribution to determine the probability x is greater than or equal to 9. So we want 9 or more. For our table, if x equals 0, the probability is 0.000. For x equals 1, our probability is 0.000. For x equals 2, our probability was 0.000. For x equals 3, our probability was 0.000. For x equals 4, the probability is 0.001. For x equals 5, the probability was 0.003. For x equals 6, the probability was 0.016. For x equals 7, the probability was 0.053. For x equals 8, the probability was 0.133. For x equals 9, the probability was 0.236. For x equals 10, the probability was 0.283. For x equals 11, the probability was 0.206. For x equals 12, the probability was 0.069. And we want to find the probability that x is greater than or equal to 9. In order to solve this, we want to take the probabilities for 9, 10, 11, and 12 and add them together. That gives us a total of 0.794. Using the same probability distribution, this example we want to use the special addition rule and the probability distribution to determine the probability x equals 6. So to find the probability of x equals 6, we simply need to find the probability for 6, which is 0.016. Using our same probability distribution, this example used the special addition rule and the probability distribution to determine the probability that 6 is less than or equal to x less than or equal to 8. So to find this probability, we want the probabilities for 6, 7, and 8. So adding those three probabilities, 0.016 plus 0.053 plus 0.133, we end up with a total of 0.202. Recapping our section, discrete random variables and probability distributions. A random variable is a quantitative variable whose value depends on chance. Discrete random variable is a random variable whose possibilities can be listed. A probability distribution is a listing of the possible values and the corresponding probabilities of a discrete random variable. A probability histogram is a pictorial display of your probability distribution. The sum of the probabilities of a discrete random variable will always be 1.